Boop, boop, boop. Jose Rogan.
Rojogan.
Yeah. I, I'm devastated.
And I am appalled
Who are the Dawdlers?
here on the Dawdlers Philosophy Podcast.
Oh, yeah.
Once again.
Oh, so.
We're just trying to make you all feel at home, right? Because everybody that you listen to nowadays is maxed out on whatever emotional scale they operate on.
Yeah, that is it. Yeah,
I'm
this
disgusted by it. Oh, this is, everything is extreme.
It is very extreme. And it's funny. I don't know if it's getting worse and I'm adjusting, but it just gets worse, or if I just can't seem to keep up with how horrible everything is all the time. And so I'm just, in the morning I'm like, ah,
Mornings can be difficult. But we just did the facetious version, but I'm Harland.
Oh, and I'm Ryan.
Yeah, now we got that codified too.
And we're still the Dawdlers. Still Dawdlers. Yes, so we're...
But are we, though? Are we still the Dawdlers, or are the Dawdlers changing already? I was surprised to hear the proposed topic for this session.
Oh, yes. Well, I guess we're the, this is an old standby. This is like a latent topic through me, I suppose. And the topic, in short, I guess you could say, is climate and climate change. Oh, fucking
climate. Yeah, I mean, that's fun. I'm ready to go. I get to have an easy one this time. I don't even have any papers laid out in front of me. I get to turn my lamp off.
Oh, man.
Crack the beers. I don't have any responsibility because I don't know a damn thing about this topic. I am here to learn.
Yes, and I know maybe too much. We'll find out. Yeah.
It's not that I am opposed to learning about this. It's not that I don't think it's important. It's that when I attempt to dig into it, be it on YouTube or on Bill Maher or in some article linked on Twitter, whatever it is, I have a hard time taking seriously and listening to most of the people, the high results in the search, whatever. Yeah, I type it in and I come back and get some PragerU video or some other. All the sources are so biased, so polluted, so engaging in various types of bias and motivated reasoning, and everybody's got their tribe, and it's all polluted with politics, and I have a hard time finding the good stuff.
Well, you've come to the right place. No. Yeah, no, it's tough because, there's that whole discussion with those IDW people, and I'm sure with many others, it's just that they seem to be talking about it most frequently, that I encounter it with them the most. But the whole long form discussion thing, I mean, we even kind of, to an extent, anyone actually notices, we advertise ourselves more or less in this way, like long form discussion podcast on ideas. And, it's one of those things where with the short form, the people get maybe just a few moments to say something. And of course they give everybody a say. And usually it's just, political. And everybody's angry in one way, form, or another, or there's some nanny poo-poo thing going on. And then, of course, that helps with the ratings, I suppose, I think it's to their advantage, Bill Maher, whoever, to have people who want to fight on their show so that, anyone watching can be a little on the edge of their seat and all that crap. So, but
Yeah.
then yeah,
And that they have to have their polished, prepared Type 5 because they know that in that medium, they're only going to be able to engage at a certain level. But yet
yeah,
that's what most of us get most of the time on most topics, except those that we really care about and go pick up 400-page books about and dive into the journal
yeah,
articles and stuff on emergence because we love it. And climate, we're like, I don't have time for this and I don't really care. So I'll just get the Neil deGrasse Tyson on Larry King version. And, that's all I get.
yeah. That's too bad because the obviously I think this topic could, you know, I think it does many things outside of even just the political realm. It would be a great way for people to kind of have a good sense for kind of what a community of scientists do and how they operate, how they um, come to agreement, how they come to include each other if they haven't been including each other in some, the far reaches of some particular topic area. Like, maybe, climate modelers are like, oh yeah, include biology, or maybe they'd be like, oh yeah, we should probably include those massive ice sheets at the poles. Um, things like that, it's an interesting community for that reason. And of course, it's always a hot topic because it's, actively happening or whatever.
And
And
it has high stakes, or so some tell me. This is
right.
the end of the world.
Yeah. Well, the end of things as we
The end of humanity, I suppose. Most people think the Earth will still be around.
like George Carlin certainly did. Um, yeah, and there was another place where you get your climate science, George Carlin, or your Earth science or something like that. It's a
Hey, he
couple
knew we were
bears and a lamb.
circling the drain 30 years ago.
Yeah, well, sure, yeah, for sure.
But
But
anyway, yes, I like that we're going to go for a long time, and it's coming from a couple of Dawdlers who are unaffiliated with any of this. It's like there's no institution, there's no whatever. I don't know. I like that about us. And here I am advertising. All right, whatever. I got a source now. I can learn about climate change from someone that at least I am willing to trust is unbiased
entirely.
in the ways that I find most distasteful.
Nice.
So what do I need to know? What's the deal? They tell me. All right, initial question.
Yeah.
Maybe you'll throw the whole thing off.
Whatever. That I won't be up to the task anymore, and
I am told that this issue is. Some people tell me this issue is settled. There is a scientific consensus. 90x% of scientists have evidence that anthropogenic climate change is happening, has been happening for at least, 50 to 200 years, and that it will alter things so significantly that major consequences. Cities will flood, ecosystems will alter, things will go extinct, perhaps humanity itself is in danger. Other people tell me, well, it's a debate. What's the right answer to all of that?
I would say it's closer to the 90x% or whatever. Because I think for the reason that, many people contribute to climate change research, whether they're studying, the atmosphere or the oceans or whatever directly as physical and chemical subjects, but they also study them, biologically. And so you have all these various people coming at the problem from various different angles, and they're all poking their heads up from their cubicles and going, "Hey, wait a minute, this is changing," and someone can be like, "Oh, it's changing over here too," and so it seems sort of like a blind consilience of inductions on one thing. And it's not that people are, just kind of coming into this idea now, so that's the other thing. It's been, there've been people talking about this stuff for a while, and I don't know about that number. I love that. It's hilarious. There's that one. People love their 90 something percent. There's that one, and there's also the one that's like all, like 99% of all, species are now extinct or whatever. Like there's always those like journalistic things that people like to throw out there. I don't know if like in any of my classes, no one ever like no climate scientist ever said that in a lecture. You know what I mean? So it's I don't know. Like I don't know. I guess
okay. So that little tidbit, that fact, only occurs in popular media, and it's not a meme in the scientific community so much.
Well, as far as my experience goes, maybe other people in other earth science departments when they're going to college or whatever, no, that is something they definitely encounter. But I never had like any of my professors could walk in the room and be like, 99% of my friends agree with me, like it's just not the thing. Usually it's like, oh crap, we have this syllabus and we have to do this work. But I want to kind of step back a little bit from climate, because climate, we're isolating it, and I think we'll get to it. But I do kind of want to lead up to it a little bit, because climate is part of Earth in terms of, processes happening at its surface, but, the factors related to it, are, beyond the Earth's atmosphere, in both the direction towards, outer space, and then the direction towards, the interior of the Earth itself. So Earth, and maybe even beyond that, to some extent, there's a solar system aspect that climate is related to, in a somewhat direct, way in which you can kind of, atomize it and study the parts and things like that and be productive. So the one thing I do want to kind of say, though, first off, is that the thing I want to put out there is that Earth is a system. We can kind of think of it in that way, as a whole, little system. And of course, it's part of other systems itself. But that within that system, there are components to that system. There are subsystems. And we often call these components at certain levels of explanation or description. We call them, say, spheres. We have the atmosphere, and, we have the lithosphere, asthenosphere, and, we also like to throw around things like the Twitter sphere and stuff. But, but nonetheless, we have these basic components that are, this system is comprised of. And, they, of course, interact. So it's kind of a way for us to kind of conceptualize and to be able to, work with the various areas of the Earth that we think kind of are contiguous with one another, but we know that they're also quite interactive with other aspects. So the Earth is a system. It has these spheres, and they interact. And how they interact is through what you might call cycles. Like you've got the cycles. Probably most people, if they're paying attention, even in like their high school physics and chemistry classes, or even biology, they'll see, there's like the rock cycle and, the water cycle and things like that. And even at a smaller level, we'll talk about like elements, like, the carbon cycle. And
is this like the kind of like the crab cycle, where certain people will get kind of angry periodically?
I wish. But it isn't as interesting as that, because I've never heard of that.
No, that was a Krebs cycle joke. All right, carry on.
Oh, for crying out loud. Is it because their metabolism, they need to eat? Yikes. Anyway, you can tell, like, I'm all like, do this right, Ryan. Do this right. Don't fuck up.
The pressure is on. 1.5 people might hear you.
Maybe 0.5. but the one person definitely will. Um, so anyway, so you've got cycles. So
Okay, so,
that's
and you're saying
yeah.
that that's what can tie these different systems together because you've got your medium, like the water or whatever, and it goes through various phases, and that ties together the atmosphere and the oceans because something cycles betwixt them. Is that the point?
Yeah, I mean, but there are all, of course, ways in which we conceptualize the process of exchange of, anything, and we then can say, well, this is, going to be an important factor in determining this outcome, for, various reasons, et cetera. And, it allows us to kind of keep track of all the things that are happening on Earth that affect, day-to-day activities as well as, millennium to millennium activities. Uh, so, we are a civilization, and that seems to be something, where we live on Earth is pretty concerning to us, especially now as we get better and better at seeing ourselves or putting ourselves in newer and newer perspectives. Um, and so, yes, that's the part of it. And then, of course, so you can have these cycles, and the cycles then, in addition to having the exchanges that they do, they are feedbacks, and that's another important component. And there's two kinds of feedbacks. One is a positive feedback, and the other is a negative feedback. So positive feedback would be like if you had a mic that you put in front of an amplifier at a rock concert, and the microphone is playing that over much larger speakers to get to the people all the way in the back of the stadium or wherever they are. And somehow maybe that sound from that speaker gets picked up by the mic, and then it gets transferred out, and you blare that out through the speaker, and then it comes back into the mic, and you have this accelerating feedback that goes that's a positive feedback that is essentially you have this little bit of a change or something, and it accelerates the change or increases the change and pushes it further and further into what it was. So where you start, you end up in a very different place. And then you got negative feedbacks like homeostasis. You get hot, your internal temperature is hot, too high or whatever, and you sweat, and that sweat, like the provides evaporative cooling properties, and then you cool down, so your temperature is maintained at least in that way. So there's these feedbacks and whatnot. So that's kind of something to just keep in mind. Earth is just this system, and it's got a whole bunch of different components, shit ton of stuff happening all at the same time, or and roughly, and every once in a while a big rock comes and hits it and kills everything. But for the most part, it's a high functioning entity of interesting characteristics and stuff, and we love it because we live here.
So you can kind of look at, is there anything to be gained from interpreting the Earth similarly to how one might interpret a human body or other living organism? That there's gross reasons to draw a boundary here, so, at the skin layer for a human being or at the atmosphere for the Earth, wherever you draw your boundary, and look at that thing as a system. And then also it can be profitable to interpret various subsections of its interior as subsystems, and then look at how the subsystems function either cooperatively together or competitively in these various feedback cycles to constitute trends in the behavior of the overall system.
Yeah, I mean, you could, look at it in those ways. And I think what you might be talking about at this moment is John Lovelock's Gaia hypothesis, if I am correct.
I think his name was James, but otherwise, yeah.
Damn it. Well, I knew it was a J. I didn't want to say J Lovelock, and I was like, it's got to be John.
I might be
James.
wrong, too. I don't know.
It's okay. Lovelock is the appropriate last name. But yeah, so Lovelock's Gaia hypothesis, which is essentially what you had just described, that there are all these, and Lovelock was a, he was like an atmospheric scientist, I believe, if I am correct. he definitely had like an engineer's background. Um, I don't remember all the details. I know he invented things, and he was able to make a living off of his ingenious inventions, none of which I remember right now, but they were important. And he was even allowed into the academy of sorts in terms of not teaching or anything, but like all the other beneficial things to be part of that most of the academics were part of, like the societies and stuff. I think he was a member of the Royal Academy in London or something like that, and that was a rare thing for somebody who's not affiliated with a university. But so because he was on the outside, he was able to kind of think wide. I think quite a bit, and he came up with the Gaia hypothesis, which is that essentially Earth is an organism or something like that. That it operates more or less like that. Um, and I don't know, it's been a while, and I haven't really looked it up lately. But I don't know if he really thinks it's an organism or if he thinks it's just like an analogy, and that organisms are, you know, interesting in that respect because hey, here's the other thing, the whole entire planet, and it kind of seems to have similar types of properties.
Yeah, I couldn't say with confidence either the degree to which he took it literally or thought it was a fruitful analogy. At the very least, the latter, though, right? That he would think or claim things like, we might do well to interpret the Earth as though it has an immune system. Because
Right.
that, what are you allowed to carry across one side of the analogy to another? I think he wanted to bring a lot over from organisms to apply to planets or this planet.
Right. Absolutely. Yeah, I think at the very least, like you said, it's a good analogy and a good way to take care. Certainly, when he came up with the idea, you know, there were things that came along later, like Earth Day and whatnot. So yeah, uh, I guess now then is kind of maybe a good time then, now that I've kind of set up the idea that Earth is a system, it's got these components, they interact with each other, and that there are these kinds of different feedbacks that can happen between the different components that can produce changes in terms of the planet itself, and that they're all kind of they all interact and interrelate and all that kind of stuff. Um, and I guess to some extent you could say very much that they're quite interdependent upon one another. Um, and so the other thing though to remember about the cycles is that they have, and this is a big one, is that they have you know uh, durations upon which, say, if we're going to talk about carbon, there's durations upon which carbon is in any of these areas that you could call them stores or, reservoirs or whatever. Like, so carbon dioxide in the atmosphere stays for a certain amount of time. If you were to unitize it to a single molecule or something like that, or something else even larger, like a scoopful of, you know, and then carbon stays in, plants and animals in the biosphere or whatnot, or the soil or whatnot. It stays in these different areas for a certain period of time before it moves on to another, uh, you know, um, part of the system. Stays in the surface of the ocean for a certain amount of time, or surface, water on the continents. And then, of course, it stays in the deep ocean for a certain amount of time, on and on. And then the big one is that the longest duration of time that it is stored is in the rocks, deep in rocks, buried, and preserved, and not allowed to really decay and be able to go back to these other parts of the system. And so it kind of gets taken away from the, almost, you could say, day to day, millennium to millennium style activities. And a lot of
Is
these,
that's where they use the word sequestered, right?
yeah, that excellent word for that. It is sequestered from the shorter uh, lived, or
The
shorter
shorter duration cycles into a longer one. Is that the idea?
yeah, I mean, it's just not part of the whatever that carbon is, wherever it is. It's not part of the normal day to day. And that's a bad way to put it, but it's not part of the actual. It's almost as if it's been removed from the system entirely. It's put away for so long, relative to the durations of other parts of the system. So anyway, I think that's an important thing for one to remember about, you know, about Earth.
So that if one takes a given reservoir and measures its current concentration, that one can make successful, accurate predictions as to the likelihood of that concentration altering over time given our knowledge of its inputs and outputs.
Yep.
To simplify, you could just say, well, if you don't put any more in to this reservoir, it will empty itself in X amount of time, or that kind of thing, right?
Yeah, that's it. So, I mean, they're estimates, at best, because obviously, you're talking about a lot of little things, if you're talking about carbon, carbon elements, atoms, what have you, and their representation in all the various ways that they join with other elements to do other things. But yeah, exactly. So that's the idea, and that's part of the cycles bit. They sometimes use the word persistence time, but it just depends on who you're talking to. If you're talking to an engineer, you're talking to a scientist, or or a particular type of scientist, or something like that.
Okay, so these are things that we want to be keeping in mind, right, as we build up to talking about climate and climate change. That
Yes.
Earth can be looked at as a whole system. It has a lot of subsystems. Those subsystems have varying degrees of average time of duration of distribution of carbon.
And other things.
Why do we?
Yes.
Yeah, why do we? Should we specifically care about carbon a lot more than others, and if so, why?
Carbon dioxide, and well, obviously that's the big what's called a greenhouse gas, and we can get to that in a minute, but that's a big component of climate change. However much
Yep.
there is in the atmosphere, little or more, that kind of thing.
Next step.
Climate. What is climate? So that's kind
We're
of.
glad you asked.
I know. I was like, why not? The bumper sticker is, that it's, average weather or something, but that as a sentence doesn't even make sense. But I got a couple definitions for you, and I'll try and be as unboring about it as possible, and I'll be brief. But I'll use two because, they come from my textbooks, and I'm like, why not? Who's going to argue with William F. Rudiman in his textbook, Earth's Climate, Past and Future, second edition, which probably anyone studying that or using this textbook, if it's still being, if there's new editions still coming out, people are probably it's probably like the 11th edition, and I'm just.
That's just for commercial reasons.
It's totally for commercial reasons. So he says, or he defines climate as
a broad composite of the average condition of a region, measured by its temperature, amount of rainfall or snowfall, snow and ice cover, wind direction and strength, as well as other factors. Climate specifically applies to longer-term changes, years and longer, in contrast to the shorter fluctuations that last hours, days, or weeks and are referred to as weather.
And then an R.J. Charlson in a kind of edited volume that was a textbook for a class I had that was called Global Biogeochemical Cycles. Has the definition that he says
the word climate is used loosely to mean the aggregate of all components of weather averaged over a lengthy period, usually decades, centuries, or longer.
And that's pretty much it. He goes on and he's talking about the climate system and stuff, but he almost immediately goes into math, and so I won't do that to people. But there's another definition from a textbook for you, folks.
So what is missing or oversimplified in the picture, the description, that weather is the thing they talk about on local news. The thing that human beings are interested in when planning their picnics. What will be the air temperature? What will be the precipitation and the wind? If we can only pick three, maybe those three things. And climate is just an aggregate of weather extended over a longer period of time.
I don't think there's anything super wrong with that at all. It's that's the basic part of it. I would say the one thing that I always think about with climate is that, it's a much more stable concept as far as if we were to give it entityhood, whereas weather is very chaotic and it changes, and the butterfly flaps its wings and everything changes. It's much more sensitive to little changes in conditions. That's why it's so hard to predict. Whereas climate, a big part of climate science right now, 2018, and as it has been for quite some time now, is, making predictions. It's a big part of the science of studying climate and climate change, is to predict what's going to happen next, because it's like a really big weather report, right?
So is that what's being predicted when you say we try to use climatological models? Are you still predicting weather, right? Isn't weather all we can ever predict?
I think they try to downscale, and I don't know exactly the specifics, because I've never run a general circulation model. I just studied them and and used the results of the models before. But as far as the gosh, I'm like losing it. What was the question?
In part, I was hearkening back to a couple of episodes ago when we talked about emergence.
Okay.
And again, this could easily be entirely mistaken, mostly mistaken. Is climate something that emerges out of weather? Is weather analogous to the atoms, and climate analogous to the pincers of the ants that perhaps emerge out of the distribution of the basal conditions, being just what it's like today outside?
Yeah, that's a good one. I think that's a great question. I don't know if I have a great answer for it. But what I would say, my impression of climate is that it's like it just really relies on the tools of the scientist. It's a way to say it's a way to talk about averages. It's a way to talk about central tendencies. It's and a range and a variance and all that. I don't know, and to talk about it over a fairly long period of time. Talk about the climate of North America, or northwestern North America 7 million years ago. You know what I mean? Like, you talk about that, and so you're doing a lot of time averaging. And so to say that climate isn't,
drawing boundaries around various sizes.
But I think all of it is very much just us trying to understand, the overall tendencies of phenomena as best we can in taking the information and trying to make sense of it. I think that's, to me, what it is, more than a thing itself. Like, I don't know if, you know what I mean? Like, I don't know if climate is a thing. I think
right. It's at least at a different ontological category. Here, you've got this tiger in these bushes, which is capable of whipping your throat out with those talons.
Mm-hmm.
But then you have the concept of the species. Is there such a thing as the tiger? Or so climate is in a different ontological weight class than weather, etc. And one could be, perhaps, a climate skeptic in the sense of not about global warming, but about, well, I don't believe there is such a thing as the climate. I am
Yeah.
I'm a weather nominalist and I only believe in weather.
Yeah, I mean, you could. But if you live long enough, and you have any tendency towards like comparison or anything like that, then it'd be hard to stay a weather nominalist. But definitely, yeah.
Okay, we're derailed officially now. All right.
Excellent.
So you were defining climate, and then we just said that climate is weather extended over a region over time, averaged.
Yeah, right. I mean, it's a it's a way for us to get a handle on something that really we can't probably comprehend very well, which is large swaths of time. But
And as usual, we can make that same old analogy that I always like to make of a gas in a box, right? And if you take any little region at any given time, take a snapshot of it, maybe there's a higher concentration than you would expect of molecules of that gas in this subregion, but you can also talk about the pressure of the entirety of this box, and climate is like that.
Yep. Yeah, that's how I'd say it. And so when we talk about, because this is important to talk about, because this would lead into, like most things related to sort of studying Earth as a system, and you're looking to the past, as much as anything, because it's, you can't necessarily see the future. You try and predict it. You can see what's going on right now, and maybe we have a little bit of a historical record. But really, when I mean we look to the past, we look to, Earth's history, And so there have been, kind of how it's, dichotomized is that Earth is in periods of like these ice house periods, and then it's in kind of greenhouse periods. And as you can imagine, ice house is when it's cold a lot, and greenhouse is when it's hot and you're sweating and all that crap. And that is basically just, if we want to talk about it, really, we're just simply talking about temperature, and sort of we're talking about what the general average temperatures would be. And so, for instance, today we are in, even though summer's been really hot, and Neil deGrasse Tyson wants you to know that, global warming is happening, and, climate change is happening, and we're in this direction. Overall, we're still very much in a like a glacial age, an ice age, and it may not seem like
wait,
that.
You're saying we are in an ice age?
Yeah, we are in an ice age, like a I don't know how else. I mean, we're in an ice house condition on Earth now. So
what does that mean, and why do you say so?
So the idea is that really all you need to be in an ice house is just, standing ice sheets for the most part on the planet. You just need ice sheets that form. And this is continental types. I mean, I suppose you could probably start to talk about it being glaciers in the Alpine, the mountains and stuff like that. But really, I think the big one is ice sheets on land, because of number one, the fact that the water is no longer now elsewhere. It's all being stored in ice. And number two, because ice can have an effect, a really big effect, if it's in a really large, if there's a large mass of ice on a continent, it can have a huge impact on the climate of the Earth and other things. So there's a large influences that it can have. And so we are today in an ice house, even though it sure doesn't seem like it. Like, hey, what about the mammoths and all that kind of stuff? Well, the thing is that we've been going through as far as the data tells us, and it's an aggregate of a lot of different kinds of scientific data, whether it be fossils, or studies of ancient soils, or ice core data, drilling into the ice and getting there's little pockets of gas, and we can get a read on what the what the atmosphere was like when that bubble formed and was preserved in the ice. Also, there's the ocean bottom, the seafloor is just completely covered in what looks like sediment, but it's just little, you just say little shells of little protists and other organisms that take carbon and oxygen and all these other elements to create their shells. And then they die, they drop to the bottom, and then more drop to the bottom on them, and then they just become this big pile of sediment. So we can study those things and see that, over time, changes that have occurred. We have lots of different techniques for dating and getting ages, and so we can constrain their, the technical term might be, geochronometer. We can constrain when things might have happened based on primarily just our ability to understand isotopes, and it's all very physicsy and calculusy. So we're today in one of these, and we keep going back and forth between what's called like a glacial period and an interglacial period. And right now we're in an interglacial period. And of course we're kind of fucking things up with our own like projects. There's something for you there, Harland.
Are glacial and interglacial periods chapters or types of icehouse periods?
Yeah, I guess you could say there's subtypes or whatever. It's in part, the problem is that we don't have a great record of previous icehouse periods the way we do today, because as time goes on, any detailed preservation is likely to have been lost through just, uplift and tectonics and weathering and erosion and all that kind of stuff. So today we have much better, the closer it is to today, the better detail we have in more recent, sediments and things like that. So yeah. Any other questions about this shit?
And did you say what constitutes being in an icehouse period? Simply that there are any large ice sheets anywhere? So the fact that we now have Antarctica as primarily a frozen wasteland is what defines us as being in an icehouse. And if we were in a greenhouse, there would be no significant ice on Earth?
Yeah, I think so. Yeah. And of course the temperatures as well, in any proxies measurements that we're able to get would also indicate that it was, much cooler or whatnot. But yeah, that I think is the primary, unless I'm totally screwing that one up. But even if I'm not, that seems like a pretty good one. Hey, there's this huge amount of ice, or there's not, And so if we're going
to... So the way that scientists, or at least you, would qualify what Earth is happening right now, we're in an interglacial icehouse period.
Yeah, okay. You could say that, yes. That sounds fine to me.
Okay.
And then the greenhouse, it's just super warm, and yeah. I could look up, I got the stuff right here, but let's just keep going because I think we're all right. I don't think that will break that, will break it, even if I'm right or wrong.
Can you say real quick, what would super warm be like as far as daytime temperature in America? Average, or what does super warm mean?
That's a good question. I think super warm, because usually we always do things in like Celsius. And it would be an average. It wouldn't be like highs or whatever. But I think it also, so for one thing, it would be reduced seasonality, I believe. And then it would be probably just, like this summer, I'm sure, just like real hot temperatures. Um, but for longer. Uh, but again, I don't have the actual like specific numbers to throw at you at the moment. That's a good question. I wish I could
Yeah, okay.
thumb through a piece of paper.
Yeah. Well, this reduced seasonality thing seems sensible and important.
Yeah, there's definitely going to be, yeah, less of that. Um, but anyway, so um, I think the next thing then is okay. So I've talked to you about ice house and greenhouse, and going back, we have an idea about climate, feedback cycles, spheres, components of a system, Earth itself. Um, so the question then, I think, when I was mentioning you had said something about okay, well, but it sounds like carbon is pretty important, and I said yeah, because of how in particular carbon dioxide, because that is called a greenhouse gas. So ice house, greenhouse. Um, but of course, it's there's not like there's no carbon dioxide during an ice house period. Um, but the carbon dioxide during a greenhouse period is elevated quite a bit. And, um, they often throw around numbers like, 400 parts per million or more. You know, that's kind of where we are heading, or if, well, we're pretty much already in there now. And those are
And
the
that
kind of,
means concentration of carbon dioxide in the atmosphere. In what part of the atmosphere?
um, the part that has the carbon dioxide in it. I don't know what specific
Okay, that doesn't matter.
part
Sure.
of the atmosphere it's in. I don't know why, but I, you know, thinking big picture, man. No.
Hmm.
Um, so, but you have carbon dioxide in the atmosphere, and it has particular properties that allow that have a role to play with temperature. And
Let
it's
me try to ask the question that you're like, I'm glad you asked that question.
nice.
What makes carbon dioxide a greenhouse gas? Are there gases that are not greenhouse? And what makes the difference?
So okay, yeah. So this is the big one. Sure, there are great gases that are not greenhouse, like oxygen. As far as I can tell, the primary ones that are attributed to being greenhouse gases are like methane and carbon dioxide and nitrous oxide, I believe. I don't know. For a while there, when I was going to school, everybody's all worried about water vapor, but I don't know how worried people are now about that. Um, and essentially, carbon dioxide comes down, I think, to the idea that you have these element cycles or molecular cycles as well, I suppose, as to how long something like methane is in the atmosphere as CH4 or whatever it was. But the CO2 stays a little longer and has, it's just a longer persistence time. So I think it's a bit more of a factor, even though if you put a bunch of methane in the atmosphere, it can be quite a strong greenhouse gas. What makes these things greenhouse gases? As I understand it, it's the configuration of the molecule itself and the way that it is interacting, up in the atmosphere. Light can penetrate through that carbon dioxide greenhouse gas layer. But then light hits the Earth's surface and it's absorbed by the Earth. And then after it's absorbed, um, the Earth will radiate heat. And so in radiating the heat, the wavelength coming in is really small. It's like beep, and then the wavelength going back out is like wow, wow, and that's infrared. So you got UV coming in, infrared going out, and infrared gets caught in that layer because the configuration of the gases, it absorbs the energy transfers happening in the atmosphere as the waves are moving back up, and so in the act of absorbing that energy, it then itself will then radiate long wave radiation. Some of that goes into the upper atmosphere and probably out into space, and some of it goes back down. So you start this process like the mic hooked up to the the amp, and then you've got the speaker, and then you make a sound with your guitar through the amp, through the mic, out the speaker. The mic picks up the PA speaker, and then off you go. And it's the same idea that you've got more and more and more carbon dioxide in the atmosphere, and that long wave radiation is absorbed into that layer. That layer then radiates that back down to Earth as well as other places, but the key being back down to Earth, which then more heat is being transferred back down and being absorbed, and then it's radiating and absorbed, and so you've got this blanket effect, which is warming.
Kind of like happens in a greenhouse.
Holy moly. Yeah, exactly.
No, okay, let me attempt another irresponsible oversimplifying analogy that I don't even know how much will help, because I don't know how many people are familiar with this technological device, nor that we've gone through yet, that I'm currently a hick who lives in the middle of nowhere and deals with plants and animals more often than perhaps you city dwellers do. I have a fair amount of familiarity with the object that we call a minnow trap. I don't know how many other people are, but it's a shape of that you can put metallic mesh into, where, let's say, on one end there's a circular disc that's maybe 10 inches in diameter that admits small swimming fishes into it. Then it kind of in a conical shape goes down to perhaps 1 inch, where there's an actual opening that admits you into the interior of the trap. So that it's relatively likely, put some little bait or chum inside there that interests them, so they can smell that and they start swimming around. And these little idiots, they're as stupid as molecules, almost. And they just swim in various trajectories until one of the trajectories takes them through one of these circular ends that are 10 inches, and then they follow the angle down and go through the 1 inch hole, and now they're inside and they eat the tasty treat and are thrilled. But then, again, because they're stupid, they can't look around, identify the hole, the little tiny hole, and swim back out. Instead, they just kind of go in a direction. I suppose the lucky ones, their trajectory takes them right back out the hole, but 90% won't, and they will bump in to the inside of the cone and be stuck. Can I use that as my mental picture of a greenhouse gas molecule? The photon coming from the sun easily goes through it, but only one directionally. Then, after it bounces off the surface of the Earth and tries to go back out into outer space, it's much less likely that it will escape, like a minnow in a minnow trap.
All the way up until the bouncing off. Because if it's just reflected, then it can escape just as easily as it went through. And that's why you can stand on the moon and see the Earth, and why you can stand on Earth and see the moon. So I think up to that point where you have the light reflect, and that's the thing that can't get out, it can. What doesn't have an easy time getting out is the long wave radiation. Is the stuff
so
that's
then it would
absorbed.
Be more like, the analogy would have to be the biological creature that's getting trapped goes into the trap and eats so much that they get fat and can't get back out the hole.
I think that's it. Yeah,
that
that's
there's
perfect.
Something that happens while they're in there that alters their constitution, and that's what prevents them from escaping.
That would be that's almost where I thought you were going with this too. Initially, I was like, is there like a lot of like meat in there, or are they just fast growers? But yeah, that's kind of more, I think, like what it would be. And that is,
I don't know if that'll help anyone else, but okay, I think I get the idea.
That is global warming. Well, how foolish, I was so busy trying to focus on the microphone feedback analogy that you were like a greenhouse. And I'm like, Oh yeah, yeah. Light comes in from the glass, hits the ground. The whole point of the whole calling it a greenhouse gas in the fucking first place. Anyway, I'm focused. So, so you've got that, but that's not all that's needed, right? But it's a big part of it. You know, there are other factors involved in kind of having establishing a greenhouse or an ice house. Um, there's a role for tectonics, um, like the configuration of the continents. The carbon dioxide comes naturally from volcanic eruptions. It's a gas that's spit out. Um, and then there's also just mountain building and erosion that occurs as well. And so the configuration of the continents is kind of a big one because it helps to understand how the ocean is being, energy that's coming from the sun that is hitting the ocean, how is it being distributed throughout the planet? Because it's a big deal for Ireland and for, Great Britain that, you have the circulation patterns in the ocean that we do because of the way that the air, like in a, like a wind pattern of sorts, um, you know, hitting off the surface of the ocean will evaporate water. And it'll also take energy, from that surface. So the surface, while it is being heated by the direct sunlight, there's also wind blowing across it. And as that happens, it removes a lot of that warmth and the moisture, creates a more warm, moist air, and the actual surface gets a little bit colder, and so there's some water that's being affected by this process that's sinking because it's getting more dense, because water is densest at like 39 or something degrees Fahrenheit or whatever, just before it becomes ice. So maybe it's 34, something like that. I don't remember the specifics, but before, because ice, water as in the form of ice expands, and so it's a little bit more than uh, than it is at its densest, which is just before it becomes ice. So so it starts
So this
to
is
sink.
more about how the different cycles interact, right?
Exactly.
Water is warm, the wind blows across it and wicks away some of that temperature, which changes temperature of the water, which makes it drop, and then you got the cycles, and then the dropping water pulls on the little shell-bearing ocean critters and changes what their life is like, and the air is changed
It's changed, and
by,
it's
yeah.
coming off of the North Atlantic current, and then it falls down and makes Ireland soggy. You know, it just dumps out there. So, for instance, Rome and Chicago are at the same latitude, more or less, and they're very different in terms of how we view them, in terms of their local climates, or the average weather that happens there. Now, there's other factors involved, but it's an additional one that Europe is essentially, allowed to be what it is climate wise, and as livable as it is because of the effects of the way that the circulation, and the interaction between the atmosphere and the ocean, as far as those go, those patterns. And you could say to a similar extent, for me living in the Pacific Northwest, it's a similar kind of effect. Um, so there's a role for tectonics, um, and then there's a role as well for orbital cycles, which are also sometimes called Milankovitch cycles after the guy who kind of worked it out mathematically and scientifically. And there's just all these various ways in which the planet, has these, uh, it's active in certain ways in its orbit around the sun, and it does this in various cycles. So there's one called precession, and that is if you take a top and you spin it as it's starting to die down and it's like wobbling all over the place. If you were to think of the way that if you can think of a top as a toy, any kind of spinning toy, I guess you could say, the the center part that cuts right through it, if you were to consider that to be an axis, where there's the little handle for your thumb and your index finger to spin it, um, that you could consider to be like the axis of Earth or something. And you can imagine it wobbling. And it does this wobble over like 20,000 years. And so, it'll complete a cycle in 20,000 years or so. I think it's 23 or something as I learned it. And then there's another cycle called obliquity, and that's kind of the tilt of that axis. And so the planet can be tilted away from the sun in a way, or it could be tilted towards it more if you are, at a certain point in your orbit. I don't want to get too confusing, but there is the way our orbit is, it's not a perfect circle, and it's kind of more elliptical, and it's sort of a little offset from the center. And so, for instance, in the summer, we are at what's called Aphelion, which is the furthest point from the sun in the Earth's orbit, or any planet's orbit, I suppose. And then in the winter, in the northern hemisphere, we're at our closest point to the sun called perihelion. And so we have summer at Aphelion and we have winter at perihelion. And that has a lot to do with, well, anyway, I won't get into all that stuff. But that's, if you were to be able to tilt the Earth so that the axis was at a 90-degree angle to the plane of its orbit, then you would be getting a more uniform distribution of the sun, and maybe it wouldn't have as big a deal. We wouldn't have as strong a seasonality, perhaps, because the Earth, it wouldn't be tilted away. You can imagine facing your head towards a light, and if you have your chin face towards it, maybe the top of your head doesn't get nearly as much light from that lamp or that bulb as your chin does. But if you were to actually like turn your head, tilt it towards the light so that it was coming at your nose, you probably distribute light a lot more over the, your head or face or whatever. So I think that's another cycle. That's about 40,000 year cycle, more or less. And
I
then
won't tell the Catholic Church you're saying any of this.
Yeah, don't. Whatever you do not. Oh, nice. That was like a little drum roller. Anyway,
Rim shot.
Yeah, rim shot. That's what it is.
All right, so you're talking. Let me just ask us. It'll be the stupid question. We're talking about the sun a lot. How does the sun affect climate? Is that the whole deal? Is this all about the way the Earth interacts with the sun and sunlight?
It's a huge part of it, yes. I mean, because the sun is where we get all the, a lot of energy for the surface of the planet. Now, there may be a lot of energy in the interior of the planet, and that may have a role to play in continental drift, which also would have a role to play in the distribution of any energy that is on the surface of the planet. But the sun is the ultimate in terms of where a lot of it comes from.
That's why we even care about greenhouse gases, right? Because they're interacting with the sunlight.
Yeah, well, they're not interacting with the sunlight. They're interacting with the results or the products of the sunlight, which is the Earth is absorbing it in terms of, say just, the land, and then it radiates off, which goes up, because of due to buoyancy and convection in the atmosphere. And so that air goes up in higher and higher, but, and it's the waves, the long wave radiation, like if you were to think of an Predator, the movie where, the Predator's got this infrared goggles situation where you can see all the, all the people, because if he had the mask off, he couldn't see or whatever. Or, people often have those night vision goggles. I don't know if those are exactly infrared, but anyway.
But is that why we care about your additional complication here of talking about the way the Earth wobbles on the axis, and that sometimes it's closer to the sun and further away, and sometimes it's tipped towards it and tipped away?
Yeah, and these orbital cycles have a role in climate because of how much sun you can be absorbing. And if you have the various cycles all acting together, they can produce particular. They can dampen to an extent, or they can kind of what's called, in if you're thinking in terms of waves, the additive effects of waves is called superposition. You can kind of really amplify the effect one way or another. So they have a role to play in climate there. There's a third one, but we don't need to get into it. It's just called eccentricity, and it's much longer. Its time scales, and that's just basically the shape of the orbit. Is it more round or is it more like egg-shaped, kind of in terms of its elliptical qualities. And then finally, the other one, which is kind of where we come in, and that's just the anthropogenic role of, Homo sapiens in climate change. And that's that's probably the most contentious one that people like to bicker over, well, yeah, there's climate change, or yeah, there's global warming or something along those lines, but it's not us who's doing it. It's some natural off-gassing from some cattle somewhere, or whatever the people want to say.
Well, of course, but the cattle is because of us. But anyway. So one of the things that you're agreeing with, right, that is also a trope in the popular media, usually from the climate skeptics who want to stress this point. But I mean, this is a thing, and we can totally agree with it, right? The climate is always changing.
Well, I mean, yeah, everything's changing. Yeah, but that's, it's not a very good premise. Because now everything's changing, and now where are you? Yeah, but yes, I keep going if you're going to continue.
No, just to stress that point, that there are things that no one claims that humans are affecting. One of the things that we are not currently affecting at our stage of technological sophistication is the orbit of the Earth, or the tilt of the Earth on its axis. Yeah. Those are not
in any major
universal factors that you think we are in a minor way? I suppose. Well, just by having babies, maybe we change.
No, I mean, just like, any physicist would be like, it's minutia, but they're like, well, every last little, like it's that kind of thing. So you have to kind of cut out the extra stuff and be like, it's only these things that really matter. You know what I mean? Like, I don't know if you know what I mean.
In no significant way are we altering the orbit of the Earth around the sun at this point. Apparently, in a significant way, we are altering the concentration of gases in the atmosphere.
Yes.
Both through driving cars and maintaining herds of cattle, and probably many other ways. Tilling our fields. We impact the cycles of the concentration of the chemicals by our behavior, right?
Yep. Yeah, of course. And it's, it's also major industry, stuff. Obviously we need these part of the cycle that we use to power our civilization, is the one part that is effectively would normally just not really be taking part in it, in the sort of, as I was saying earlier, the day-to-day activities of the carbon cycle or whatever. It's not day-to-day. It's, can be millennium to millennium. But, these parts of the cycle are much more frequently in exchange. And this one, we're actually going to the sequestered part and pulling out, and we're adding it, ever so slowly or a lot, quickly, however you want to talk about it. But we're just continually adding it to that system. So that system is now getting more and more and more and more into the atmosphere in particular. And that is having the big effect on greenhouse gases, which is having an impact on temperatures at the surface of the planet, which then have their own effects on various parts of ecosystems and, the physical systems as well. Like, increasing the temperature at the surface of the planet will, increase the expansion of the surface of the ocean, which also contributes to, in addition to the melting of the glaciers, adding water to the ocean. It contributes to the sea level rise and things like that.
There are many systems that affect climate. The one that humans affect most and primarily is gas concentrations in the atmosphere. Is that right?
Yes,
Okay.
that's the big one.
And would that be, can you even compare these? And if so, where would it rank amongst the factors? Or I suppose that probably doesn't even really matter. Because if something drastically altered the Earth's orbit around the sun such that it became significantly close enough, it wouldn't matter what our atmosphere was like, we would still all burn. Right.
Right. Yeah.
Or if we put so many gases up into the atmosphere that almost no sunlight could either enter, or not enough of this long wave radiation could escape, we'd roast that way. So maybe you can't even really compare them because all of them are potentially catastrophic.
Yeah. Right. Yeah. So that kind of
Anyway, yeah, carry on your build-up story here of the... You think you had said the word finally before.
I did. I was saying that that would sort of bring us to the point where we are now. We have a good sense for, at least in listening to this episode. You have a good sense for Earth. It's a system. It has lots of different kinds of interactions and different dynamics, and you've got ways of looking at these systems. We've climate, and we've kind of tried to define that to some extent, and we have these other categorizations that we use to understand overall the history of the Earth and where are we within that in a context of ice house, greenhouse, etc. And so I wanted to then just talk about some of the roles that these various factors play, like tectonics and orbital cycles, and then finally sapiens, in the actual, changing of climate or maintaining climate, all these kinds of things. So one of the things that this is, it's back to Earth again. Is we're in climate, but kind of back to Earth. Many geologists have argued quite extensively that because of the effects that Homo sapiens is having on Earth, with obviously the carbon dioxide in the atmosphere, pulling it from the sequestered areas of the cycle, and the kinds of agricultural practices that we have and their role and affecting chemistry on the surface of the Earth, but also in just sort of
to for a second to drill this point home, Wink. When you're talking about the way we interact with the sequestered carbon, it's that when we extract and utilize fossil fuels, is that what we're now talking about?
Yeah, and I mentioned it very briefly, I guess, earlier, so it probably is good to drill it home. I couldn't have done this without you. So we have all these various ways. Erosion. Every time we build a new condo complex, we're eroding material and it's going into the streams, into rivers, and we're just pushing it all out. We cut down the forests, etc. Sometimes we let them grow back, but we're fucking with the system in many different ways. And so what a lot of geologists would like to say is, this is probably going to, as Noam Chomsky always loves to talk about, if an alien from Mars or whatever, but just say somebody from Mars or wherever came to Earth and they were, they had a good sense for what we would call stratigraphy and things like that. We're thinking that the influence we've had on the planet has been great and widespread enough and consistent enough that we would make all these activities would have a signature in the stratigraphy, the rock record. And so we kind of want to say, well, maybe this is a period of time that deserves its own name. And so some might say we now live in the Anthropocene, because prior to that we were living in the Holocene. And the Holocene was this interglacial period that was marked in many ways by fossils, but we could also say it's kind of at the beginnings of things like agriculture potentially, and sort of we really start to move into the periods of time where we begin our civilization, etc. It also marks the end of the, you know, the time of great megafauna. So they've had that extinction event. And prior to that was called the Pleistocene. Some of these things aren't super important. What is important is that we feel strongly enough about the effects that people are having on these systems that we want to give it a new name. You know, so it's even at that level that you know, Sapiens has a role to play in you know, affecting the Earth, etc. But I think if you, I mean, I'll let you have any comments that you want to make, of course. But otherwise, I think that part of it, I think we can end or whatever.
You say Anthropocene, I say Anthropocene. Let's call the whole thing hot, hot, hot.
Nice. Let's call the whole thing hot. Hmm. Is that your concluding remarks on that part of it?
Indeed.
Indeed.
Carry on.
Science. And so one of the things that I've seen a lot lately is on, like, you know, in the Twitter sphere. Is that what they call it, or is it the Twitterverse? I might be screwing that one up.
I think I've heard both. Twitterverse I've heard for sure.
The tweet sphere. Anyway, something I've seen quite a bit is people very proudly, you know, throwing out like, this is my, you know, region's climate barcode. And, you know, it basically shows, usually from left to right on your screen, you know, these blue bars, like a barcode on a, you know, like any product that you would buy. I have like literally 4 in front of me, you know, total random, but, you know, going from left to right on your screen, it would go from blue to, you know, it would transition into a more red colors, and the darker the blue, the colder, and the darker the red, the hotter, and all that. And of course, the trend in all these places is going towards darker and redder and hotter. And so this is one of those things where I think, okay, so people see that, but what do they, I mean, what do they think that is? You know, I think I have a pretty good sense about what it is, but only because of my education. So like, I get that, okay, yeah, all you really need to know is that it's getting hotter. But like, there's a little bit more, if you just like peeled it back a little bit, you'd see a little more information. And if you peeled that back, you'd see, you know, you could get further into the story rather than just, you know, hashtag me too, or, you know what I mean? Like, it seems to me like there's always a lot more to the situation that, you know, the short form media, or whatever we call that, doesn't just ever bother to get into. It's all just super surface. And so Twitter to me seems, you know, social media, there's not, I mean, there's only so many characters you can use, and people, you know, provide links and things like that. But, you know, we're just, you know, we're like little rabbits now with the super short attention spans. But that barcode thing, as far as I can tell, that looks like what would be called an anomaly plot. And that is, you're just sort of, you know, squishing something that's sort of 2-dimensional down into like 1 dimension. And one of the things I kind of like about that little trivia is that it kind of leads into, there was this guy who is sort of the, I don't know what you would call him. You could definitely say, I think he's the first person to kind of sound, not the alarm, because apparently he was positive about climate change. He thought it would be great, or I don't know if he's great was anything he ever said, but he definitely felt positively about it. But he definitely drew a line between temperature changes and carbon dioxide. His name is Guy Callender, and I don't know a whole lot about his personal life or anything. I think he was British, but if he was French, I don't think he was, but you never know. If he was French, he'd be Guy, I think. But anyway, and he, you know, all the stuff I told you about global warming, I mean, he lays it all out there, not in any original form, but this is what we have a good understanding about. These are our models about the role of carbon dioxide, in terms of its thermal properties and its capabilities in interaction with light. Um, and so, as I described earlier about global warming and the positive feedback cycle process, the greenhouse effect that comes of it was actually called, before it was called greenhouse effect, it was called, I believe, it was called the calendar effect after the name of this guy. But he, just, it was just, too soon in the infancy of these ideas for he didn't like win the day overnight by any means. And he was just an engineer. He wasn't even like a climate scientist or a meteorologist, which is probably most likely what somebody would have been if they were even remotely interested in something like climate. And he, anyway, had this, this bunch of data, temperature data, and he collected a lot of data on carbon dioxide. And it was all it wasn't data that he went out and collected himself. He just aggregated it from everybody else. So it was kind of a meta type approach to data collection, which people do all the time now. But I think at the time, it was certainly something he was pulling from. Darwin, in his Origin of Species, is definitely collecting a lot of other people's data to support his idea. And this guy was doing very much the same kind of thing. But for him, it was also very quantitative, lots of models and things like that. And anyway, he has this anomaly plot. And it's essentially, all it is you take an average of whatever the time period you want. I mean, you could probably have premises and a conclusion for an argument as to why you said, I'm going to take the average temperatures between, time t, sub 1 to time t sub n or whatever. But people do, and then once you do that, then you basically just subtract temperatures from that, and then you plot them in the sequence in which, like the year to year to year or whatever the time sequence it is. And you get some that are, there's a zero line, and then you get some that are above and some that are, bars, some in a bar graph. You get some that are above and some that are below this zero line. And that's what this guy pretty much did. And I think a lot of people are, if you take the global, like planet-wide one or something like that, I'm guessing a lot of people might be using some of his data that he aggregated to put into some of these barcodes. I'm not certain of that, but I wouldn't be surprised, because it's pretty much he collected the best data we had at the time. And, he's one of those people where people will refer to his data and probably his ideas and his work without ever really commenting commenting on him. I go through a number of these people's, like my textbooks or this next person I'm going to briefly talk about, in their papers, and I don't see anyone being like, Guy Callender was the first to point out or anything like that. But he was certainly important, and he's even been, I think, talked about in some more popular books recently.
Yeah, Twitter doesn't care about this guy.
Well, it doesn't, and yet...
And I don't know if I do either, but let me attempt to see if I'm totally getting lost or sort of get what you're after here. This is another critique of contemporary media, such that it is interested in highly mimetic data visualization methods that work on a chimpy level to support the position that you already wanted to take for non-epistemic reasons. That when an idea becomes as politicized as climate change has become in America 21st century, it's more important that you signal your position on the issue to your tribe than that you attempt to say anything with content. So that these people who are posting these blue to red graphical representations of temperature data are not interested in where the data came from, what the individual who accumulated it was like or claimed or thought, but they just want to be able to show to the other climate change activists that they too are very concerned about this. oh, the Earth is getting hotter, and I care, and I want to fix it.
Yeah.
Do you want to go on a date now?
Yeah.
Yeah, right. That they're interested in totally other things, but they just want to show to the other chimps that they care about climate change.
Yes. And it kind of, I think it's just important to just, not leave the actual stuff out. And, I mean, um, I think that, and maybe this is another topic for another time, or maybe it's a good topic for right now, but we go around and we do stuff. Maybe it's the right topic for right now. There's a guy, I'm going to veer for a second. Are you ready? But it's going to be worth it. There's a guy who's an economist named Paul Romer, and he's very famous in his own right because he created the new growth theory in economics. And his whole thing is basically, we can have Star Trek, and he doesn't say this, but we can have a life like Star Trek because we have technology, because of the way we interact with technology, because of the things that we create with technology. And the big part of the technology thing is really, for him, is that we can create new instructions as to how to go about doing things. And so whoever comes up with the original instructions that everybody then else goes around and copies for essentially free, kind of they just get lost and forgotten and all that. And I kind of think that it's not the individual themselves that's important. It's the spirit in which they went about doing the work that I think gets lost. And so, as you were saying, it gets replaced by this chimpy beta chimp bullshit. And I personally think that's kind of, we do that to our detriment. And this Paul Romer guy was saying, yeah, we do that to our detriment. So we should invest in education, invest in the Guy Calendars of the world who are trying to say something, and invest in these kinds of things because they'll always keep pushing us forward. And be a chimp all you want, but we need to point to the things that are kind of important because they allow us to at least even learn that the things we create might be fucking things up, for us later on down the line. And so anyway, that was, I don't know, I veered, but I just thought that was kind of something else. It's called endogenous technological change. And he has a whole argument with premises and conclusion. It's pretty nice because there's plenty of math and stuff too. But I was like, oh yeah, cool. I saw premises and conclusion. I'm kind of foreshadowing for some other episode we have eventually. But it's one of those things that I just thought, it's the spirit in which somebody like Guy Callender, he's being more, people are remembering him more and more now, I think, which is good. But people who are just putting those barcodes out, now it's not all Guy Calendar's data. It's, recent data too. So he's been dead for a long time. The paper they put out was like 1938. But
oh, well, yeah, I didn't catch on to how long ago that was.
Yeah, so it was 1938, and by the beginning around 1958, this guy David Keeling, who was on I think he worked for the National Ocean and Atmospheric Association. He was on the big island in Hawaii, and he was at this observatory in Mauna Loa, the really big volcano there, and taking measurements of carbon dioxide. I'm guessing because people like Guy Callender pushed it forward along with others, I'm sure. And he's the one who, if you go do the Al Gore, if you go see the first movie, I haven't seen the follow up, but if you see the first one, an Inconvenient Truth, he uses that. There's that curve data that just goes up, very steadily, but it goes up and down as it goes up. That's the David Keeling data, the carbon dioxide readings that he took from like the late 50s till, well, they keep taking it. So you can go to the NOAA's website and see the data, but then they'll use his original data, and then it just keeps going from there because other people took up the baton or whatever and kept going with it. But it'd be like if we forgot who David Keeling was. Of course, I'm sure you've never heard this person, but he makes it well enough into the textbooks. So anyway, Um,
You've got to be a dawdler to be able to care about that stuff. That's one of the
yeah.
problems, in my opinion, with our current society. We're much more tweet-sized than book-sized.
Yeah, for sure. I mean, and just to comment off of that, I remember when I first learned that this guy, Patrick Matthew, came up with a very, very similar idea of basically natural selection, like Darwin and uh, Alfred Russel Wallace after him. But I just remember when I first learned that there's this guy, and he's got this book called, Naval Timber and something. And it's like in an abstract in the way back of the book. And he basically kind of outlines more or less natural selection, like years and decades before Darwin. And it's just like, I love that shit. I don't know why. I just love that people are, you know what? It's comforting to see that people are thinking, that I'm sure he was an aristocrat and his belly was full and he wasn't one of the starving peasants and all that. But it's still comforting to see that, okay, people were doing some good thought, deep thinking back in the day, even if they did have slaves or whatever that we would consider to be appalling.
Appalling.
All right. For the
take me back to the
this
topic.
Is going to be the only.
Oh,
this is going to be the only time I ever do this. But it's not like Harland and I condone slavery, and we're like, this is ridiculous, and people think it's appalling. I just had to say that. Okay, we say appalling for other reasons because we're making.
Speak for yourself.
No. That's right. We can have that discussion too. See how popular you become. All right. So, what was your next point going to be?
Oh, I was just requesting my expedition head to take me back to climate change from Twitter, from all these names that I haven't heard of, and where we are now. But I think that you have put together all the pieces that you wanted to establish.
For the most part, yeah.
Is there a way to wrap them all together and put a bow on it and then move to whatever we talk about next?
No, not really. To be honest with you, I did have thoughts to be able to, if it went there, I was sort of prepared to talk about, the measurements and the proxies and the general circulation models, but I'm thinking, oh, well, that could get into a major yawn fest for our single listener, potentially our 0.5 listener as well. But, in general, I do want to just quickly mention that, a lot of the other ways that people think about, the changes on Earth's surface that are taking place and that are strongly related to climate and carbon dioxide and temperature and all that, would be, not just the temperatures changing, but, weather patterns changing in the Pacific Northwest where I am, even though I'm not from here. I think I've noticed changes. It's drier, and that has an effect as well. And it may not be, and I'm not trying to confuse this with any anomaly plot, but it may not be an anomaly necessarily because it's been pretty consistent. Also, these sort of major changes this is something that Neil deGrasse Tyson would point out, like, the technical term I would throw out there would be like ecotone changes, migrations, etc. We see those potentially. We can see those in the, I don't know. Hard to say how to. I'm not sure exactly how to say this, but the rock record might reveal some of these changes as well. But where like ecosystems are kind of moving north, and obviously the pictures of the glaciers, where you've got like in the early 1900s, these are glaciers in mountainous regions, and then you look at them today, pictures of them today, and they're just like basically not even there. It's like, well, where did that, go? The other one that people talk about a lot is increased storm intensity, which is a big scary one because of, hurricanes and, Hurricane Sandy or Tropical Storm Sandy. I don't remember which it ended up getting called, but it pretty much fucked up Manhattan even, I mean, it was pretty intense. And that really hadn't happened much before, and if it were to happen like, 2 or 3 or 4 more times in the next 10 years, I'm sure people would be like, oh, fuck, like, is this going to happen so frequently? Do I need to have investment in a dinghy if I live in Manhattan? I mean, so yeah, sea level rise, all that shit. Um, we use the general circulation models to predict these kinds of changes, and we use other kinds of measurements to sort of validate them by collecting the data itself. And we sometimes don't always have access in the past to actual temperatures, but we can use our understanding of physics to come up with ways to cleverly uh, coax the basic idea of the temperatures out, and that's through some of the processes even that we talked about today. Anyway, that's pretty much it. I'm now kind of like got the monkey off my back, and we can continue on with other stuff, which would be fun, or whatever.
Well, all right. I don't know where this will go, how it'll go. And I'd like to stress that it's a legal move to point out why these are bad questions rather than responding to them. But let's run a pseudo popular media interview with someone who clearly would never be invited on a popular media show and see how it goes. Right?
Okay.
So like, all right, well, welcome, Ryan, whatever is so just tell me straight out. You like to say a lot of big words and talk about studies and historical figures and all the data and all this shit. Well, just tell me straight out. Is the globe warming or not?
Yes. Is this where everyone claps and stands up and applauds?
No, not
Okay.
yet. They're just still confused,
Yeah.
right?
Okay.
Is it humans' fault?
Yes.
Oh, all right. So now we've made a political statement, right? And we got all. Why? What are we doing wrong? What are we doing to cause it?
Taking fossil fuels out of the ground. We're using them up. The waste product of carbon dioxide is going to the atmosphere. It's acting like a big old blanket in the atmosphere, increasing the warming of the planet for reasons of solar radiation coming in, hitting the Earth, absorbing on the Earth surface, and being radiated up, creating a positive feedback loop, which increases the temperatures on the planet. Done.
Why do you hate America? You sound just like a liberal shill. This is just the standard. Like, to me, that sounded a lot like you're just saying what the alarmists are saying. Are they right? Is the quote-unquote left just accurate here? Is Al Gore right? Is this whole... It's humans' fault, and it's a big deal, and it's because we burned too much dinosaur bones.
Yeah, that's probably as I mean I would go with that rather than the alternative. I'm not saying
The
that
alternative being?
uh it's not humans' fault because it's not happening, or
Okay. Should we be alarmed? Is this a big deal?
probably.
Is Florida and LA and Manhattan gonna be underwater? And if so, when?
Probably if we don't do anything about it. I don't know, probably within the next 50 years.
That sounds soon enough.
It's pretty soon.
Is it too late
Yes.
to do something about it? Yes? Ooh, nice. That's a good one.
Yeah, I think it's too late. I mean, we can do things to mitigate in general, right? We can always do things to mitigate. Can we reverse this trend? I mean, in the whole like anything's possible language, right? When we use that type of way of thinking, then sure, yeah, anything's possible. And, someone could come up with something that's sequester all the carbon dioxide that we want to be sequestered out of the atmosphere. And, but even still, like, there's still that momentum that is, happening within all these systems that we talked about earlier. So things are still transferring from prior. There's a lag. There's, it's not always going to be an immediate pull up. Like we're just coming up to the cliff and you're like pull the horse's reins back. Oh, that was a close one. I don't think it works like that. Yeah. What other questions?
It's too late to. So what is the worst case scenario if we proceed as we have been for the last 20 years, changing virtually nothing in the direction of mitigating or preventing the exacerbation of anthropogenic climate change? What will happen in the next 50 years?
They, based on these GCMs, these general circulation models, and other studies, big word there. A lot of the stuff I was telling you about, we have increased drought, likely. Areas that are arid, many of them will continue to get even more arid. Surface water will, streams will no longer really be running even part of the year if they don't run already part of the year. You know what I mean? And others will change with respect to that. The transition of where we store water, or where water is stored. So if we've got glaciers in the mountains, if those melt away, they still get moved through the rocks, and so there'll be a period of time where even though there may be no glaciers up on Mount Hood or whatever in the Cascades, there may still be water that we are accessing to a degree in the system because it's still coming down. I don't know ultimately then what happens when you don't have that water as much to pull from. I talked a little bit ago about increased storm intensity and whatnot. Houston, that I don't think I ever saw anything like that when I was a kid. And I don't think my parents ever saw anything like that. You know what I mean? It's not like you can call in the old days like, oh, well, you remember when Houston flooded that bad back in 1849? I don't think anyone does, of course, no one's alive. It was anyway. But sea level rise, yeah, that's going to have a huge impact. Because I mean, what do you do to stop it if you want to continue to stay there on the coast? If it is rising, and then where do all the people, not the people who are at the coast who have the money, and they're like, yeah, I have my big house right on the ocean. That beach, that plot of sand's mine, well, the people who are behind them, where are they going to go? Because suddenly, are they just going to stay and be like, haha, no, it's me? Or is someone like Trump going to come in and be like, get the fuck out, are the billionaires going to do what they want in times of crisis? It's hard to say. Obviously, having this administration, I know this is very political now, but it doesn't help. I guess I would say. I mean, it seems to me like it's not a good one. I kind of call on the Peter Turchin, he was a population biologist, and then he became a historian, but he's sort of a quantitative historian. He's created his own little discipline called cliodynamics, and he studied using a lot of the same kind of stuff, this sort of like measurements and proxies, because he's trying to get at things that he can't necessarily just go to the historical record and grab, but trying to get a sense for, the welfare of societies. And, he notices cycles in in societies in terms of how well they're doing and then how poorly they can be doing. And, one of the things he sells at this moment is that, we're definitely moving, we're well within the move towards a bad time. And then it'll reverse and we'll maybe head towards better times, hopefully. The thing that's different about this time around is that we do have this climate change stuff. If it is having an effect on things like agriculture, and because the other thing that comes, every day you see new reports, like, well, people are starting to think about, like, well, the pests. Pests are starting to move further north, and maybe malaria and other things that people at certain latitudes haven't necessarily had to deal with before. So then you've got pests in crops that maybe the crops just never had them, and we have a handle on things at the moment, but now we're going to have to definitely adapt and change to deal with that in our society. And it just kind of all these, we've talked a lot earlier about these big picture systems and how we understand them, and thinking about the physics and chemistry of the relationships, as well as some of the biology. After all, that's the carbon we're putting back up into the atmosphere. It's just dead plants and stuff. But I mean, we also have these little things that are happening today. Just our little crops. Our corn and our wheat, our gluten-free wheat. Um, and so that's going to have an impact. I don't know about impacts that pests might be having on, like, livestock and stuff. Maybe there's probably going to be too. So it just kind of keep, you just keep going. There was something I was thinking of a second ago, but I can't remember.
Yeah, it doesn't matter. We went to commercial 5 minutes ago.
I know. I'm just like, yeah.
You're not allowed to give answers like that. Then I was wondering if the epidemiological aspects would come up, because that's something that concerns me about this. And then just the general point about the more closely interrelated and the more complex your systems become, in the sense that minor changes in the initial conditions can easily blow up into drastic shifts in subsequent evolution of the system. People will sometimes, in, again, the media, the bias, the political, the bullshit folks will say, yeah, whatever, it changed 1 degree Fahrenheit in 50 years, as though that's dismissive and it doesn't matter.
Right.
I think, but again, I'm the ignorant one, so you can confirm for me, that can be a BFD. Right?
Yeah.
That's a big fucking deal. Like,
huge.
You can't just... 1 degree doesn't sound like anything, perhaps intuitively, to a Twitter viewer, but no, like, that can change a lot of important things.
Yeah, that changes. Yeah, I mean, that changes so much. And I think, they're, the fact that they're talking about changing even, that temperatures could change even more than that, is pretty, it's intense. I don't know what's ultimately, and we may not be alive to see it, but certainly I don't know what's ultimately going to be the case. Hopefully there's some ideas out there that people might be thinking up that are just like, oh yeah, that's totally a way to stop this or solve that problem or deal with this issue. Because otherwise it's just sort of like, well, I don't know. My biggest, like, the biggest worry anyone would normally have, I think, is that, you just be doing little patches on problems now, without really kind of, like, addressing the systemic issues at hand, and so that seems to me like the biggest thing that one might not want to fall into,
If you have an opinion on this question, name between 1 and 3 large-scale behavioristic changes that humanity could engage in to mitigate the detrimental effects of climate change on human society and our goals.
Yeah. I don't know. I'm going to start with one, and hopefully I can come up with 2 other ones, or ones that I've thought of or have learned. I remember I have a cousin, my mother's first cousin, so I guess it makes him a second cousin. I don't know. And he was an economist, but he was an economist who dealt with environmental problems. And he was a professor and all that business, emeritus now, I guess. And I remember when I was doing my teaching assistantship, I uh, thought of like, because there are all these alternative ways to, power, you know, stuff, your house or whatever, right? And, one of the things I see in Oregon and, throughout a lot of the Western states that I've driven through are like, big windmills, and apparently uh, I signed us up for getting most of our electric power from windmills. Um, but anyway, that's neither here nor there, but it's just a factoid. Um, but I thought I was like, what would happen if you used all the alternatives? So like if you had like your house and you know, you had like a windmill at the top and you had a bunch of like solar panels and like you had other ways to like, get power from, the earth or whatever using alternative means besides relying on something like fossil fuels or whatever. And he immediately like sent me a paper that like this ecologist and economist wrote about like ways to use alternative stuff and just like they called it wedges. I don't know why they called it wedges. You could probably look it up. I think it was a paper in like Science, like one of the big ones. Um, but anyway, I just thought of that and I was like, yeah, that could be I don't know how viable a solution it is, but it is like, well, if you can't get a lot out of one, what if you tried them all? I don't know if that would be a ton of work or not. And certainly having everybody, it's like the whole recycle thing. It's like, well, if we all just recycled, and it's like, well, what if, we had, you know, a system set up to deal with recycling in a way that didn't rely on everybody to do it themselves each day in and day out. And, which is fine, but, cultures are not, I don't trust cultures to do that forever. You know what I mean? Um, so anyway, it's just one of those things. So that was one kind of solution that I remember I'd thought of. I don't think it was a great solution by any means, but perhaps it could be something. Um, and I think that there are people who have tried to use waste in like places like Germany or whatever, places that are like super hyper progressive and like, yes, let's do this cool new thing and make it work for our cities and towns. But they were using uh, waste like garbage, and they created these huge plants and these processing centers that then extract the methane that is, the bacteria and stuff that are, decomposing all that trash. And they take the methane and they use that as their fossil fuel or whatever. It's not a fossil fuel, but it's like, the same idea, to be able to power as like sort of a natural gas to power some stuff. I don't know if they power all their everything with it, but that's one way, is to just kind of, take the basic idea of what you're doing and just get it in a different way. So you're not taking from the cycle, place, stuff that's buried or whatever. And then a third one would be just stop being a society. No. I don't know. I don't know what the third one would be.
Now we're talking.
You remember at the end of Escape from L.A.? Did you ever see that? Kurt Russell.
Yeah.
Not the Escape from New York, but Escape from L.A. And he has this whole like, somehow he gets a hold of the power button and he's like turns society off or whatever. Takes a drag from his Tipperillo and just marches off. Now, that would be an option, and that might slow things down. But yeah,
we finally moved from Obama liberalism to anarcho-primitivism and got a little more radical. Let's do it.
That's right. Yeah. So there's that.
When us Bill Maher Watcher level climate change engagers do what we do, we hear a whole bunch about the International Panel for Climate Change report in 2011 or whatever it was.
Uh-huh.
Should that be as big a deal as it is? Should we give a shit? What's the basics of what it said? And should we care?
As far as I haven't read any of the latest ones, but I think the basic move they do is they provide, they do, basic reports on the state of the situation and all that, but then they talk about, all your options, various scenarios, like if we cut back emissions by this much, or if we, what I mean, like if we, if we do all these various things, or if we do nothing, and so you have essentially multiple working hypotheses or scenarios and whatnot. And that's kind of the primary thing that I think they tend to provide. Now, that doesn't mean that people in the overall the overall community at large don't often say, that's not right, or whatever, as scientists would, right? They bicker about certain things, and maybe some people are biased in particular ways who are on the assessment panel for the IPCC, which is, by the way, the United Nations Intergovernmental Panel on Climate Change. But yeah, it's it's one of those things that I think that's the main purpose that they serve, is to show you various. I mean, not main, but it's a big one that people tend to talk about a lot. Is that they provide you all the various scenarios given different emissions scenario amounts or whatever. Even if we stop entirely, if we let Kurt Russell push the button or whatever, like what would happen? So that's kind of what they tend to do. But again, it's been a while since I've read their reports. I imagine they're not much different than the ones that I have read.
Freeman Dyson tells me if we change our farming practices, we can fix all of this. That, sure, climate change is happening. Humans probably have an effect on it. We ought view that warming climate as an opportunity for bioengineering. We will now be able to grow more crops in more places than we were before. And there are common sense alterations we can make to minimize the negative effects while taking advantage of the positive. For example, instead of growing corn to feed to our cows, we can use that real estate intelligently as grazing land and just move the fences around and let them eat the grass, because tilling and doing standard farming where you open up the black dirt and then plant the seeds into it, and then again in the fall harvest all, and then have all this dead material and release all the carbon into the atmosphere or whatever. That's one of the worst things you can do, I'm told, is making black soil rather than letting it be native grasses that are then grazed upon by cattle. Is there some combination of these sorts of things? Doing intelligent, scientifically backed practices of, what do they call it? Being good stewards, when you use things responsibly, sustainably, in the right ways.
Conservationists or something.
Could we actually take advantage of a warming climate to have access to simply more energy to turn the earth into a greater Eden than it otherwise would be?
Well, I mean, I'm not. Well, first off, I don't know. You can't. I don't think one can straight face say that climate change is going to produce all bad things. Like that. That's all it's going to do is create bad things. I don't know how many good ones there are, and relative to the bad, that have been listed out in this episode so far. The issue here is that it's the same issue with everything else, and that is, I guess, in some ways, it's politico-economic or whatever. In that, well, that's great, but why can't we also get solar off the ground in the ways that would be amazing? Because wouldn't that seem to be the thing we'd want to do, is just power our civilization with the sun, which is another thing Freeman Dyson talks about, which would seem to me like the thing we might want to do. I don't know if we can get to powering our civilization with the sun using solar panels um, faster or slower than some of these other practices that he might talk about us trying out. Of course, now they've all become sort of practices that he's talking about. Maybe do all of them like I was talking about before, like, just try them all, like try and take
Yeah.
advantage of the warming while you're also trying to figure out how to like maybe mitigate it or have some degree of, slowing it down. One would think that if you can, this is what I say to my son all the time. He'll make a big ass fucking mess in the house. And I'll say, "Hey, well, it's time to pick it up." And he's like, "Do I have to do it all by myself?" Like, I don't know where he gets teamwork. And I'm like, "Well, you made the
Cool.
mess by yourself. Can't you figure this shit out? Do you not remember where you pulled that thing from?" And it's kind of like that's like where we're at or whatever. Like we're like, "Do I have to do this all by myself?" And it's like, "Yeah, come on. You can't. You can figure out how to like."
Can't God help a little bit?
Yeah,
What a lazy asshole.
God.
God damn it.
Yeah. So I mean, it's like we could combust in an engine. Why can't we like sequester in a whatever something? Why can't we get the sun to work for us? Why is it only in the one direction? And that means to me like somebody's vested interest is involved or something. So that would be my only thinking is that, yeah, okay, sure, Freeman, but we got to like get past the same old twats that, like nothing's changed in that regard. The lobbyists are still lobbying hard for same, business as usual. And so,
Right. I mean, all right. So I'm personally, again, super ignorant, don't really care. But it seems obvious to me that we should be doing quote unquote renewable energy stuff. Solar, wind, water, whatever.
Yeah.
All these sources of extractable and storable energy, we should be doing those. And anytime, just as a general orientation, whenever money is the primary reason to do it in the way that we do it rather than another way, I'm opposed.
Yeah, right.
And that's the only reason I can think. Institutional inertia and economic vested interest and efficiency that we would bother to cook dinosaurs rather than
Yeah.
harvest sunlight. It just seems foolish to me.
Yeah. It's dumb.
That's an obvious one.
Yeah, I think it's an obvious one. And I think it's probably as simple as psychological biases would have it, Yeah. Like in our Twitter feed for the Dawdlers, I saw something today where it was like talking about how even smart people can be, you know, can clutch to ideas, and in some ways it's worse because they can like justify and rationalize their way to like keep a stupid thing, or whatever.
Yeah, they use their intelligence for the nefarious purpose of justifying their bullshit.
Exactly. Said very well. So I kind of think that like I don't see why it's not anything more than that, or has to be anything more than that. Using Occam's razor in this case, it's just I make money. I don't want to learn anything new, and I don't want to have to. I'll put all my effort into. I'll sink all of my effort into this one thing because it's familiar, or because it seems easier than something unfamiliar, or whatever, and that just is all too human.
Too human.
Indeed.
So, all right, I'm wondering. I'm going to do an attempted summary and then check to what extent I'm mistaken.
Okay.
I almost feel vindicated not paying attention to or caring about this topic. Because from what I've heard tonight from our putatively unbiased and respectable source, very well accords with the picture that I have extracted from my admittedly poor engagement with these ideas. Number one, climate change is happening. Number two, it's significantly, though not entirely, humanity's fault. Number three, we've ignored it so long that it's probably too late to avoid significant difficulties, though not too late to salvage, obviously, Earth. I mean, the Earth will be fine, but to salvage even humanity's existence. But we're probably going to have to pay some significant costs for the way that we've behaved over the last 100 years.
Mm-hmm.
It sounds basically like the Bill Maher liberals or whatever are right. That anthropogenic climate change is happening and it's too late, we've done a lot of bad shit and it's too late to totally avoid consequences. We should try. We should build more windmills. I don't know. I'm not summarizing well, but
that's fine.
That's basically what I'm getting from Ryan tonight. Is that wrong?
No, I don't think it's wrong. But I don't think, I would like to think that what I gave you, even though you may have ended up in the same place, you aren't the same Harland in that place anymore. How does that feel?
Oh, agreed. I'm just saying that when you attempt to be epistemically responsible, you can, in a complicated world where there's a lot of ideas to consider and there's a lot of people throwing stuff at you, it seems good to me to realize the places where you have bothered to dig deep enough and think enough and consider the arguments, make some of your own, and have a considered position. On those scores, I feel I have improved after this engagement.
Mm-hmm.
But then there's also just the end product, that while you're walking around and behaving, for example, voting, not that I do that, when you go do stuff, engage in the world, you're operating on wherever your current opinions lie. And I'm saying that I don't think I've been requested or required to change any of my opinions, but I have better reasoning behind them now. So that's good and great.
Yeah.
It's just interesting to me that the position that it seems like the Dawdlers' philosophy has arrived at this episode is very similar to one of the standard media positions that Neil deGrasse Tyson types would be out there making.
Yeah.
So that's interesting.
I think so. And why no one's like, I don't think anyone in the climate community is like, shut up, Neil. They're like, okay, good. Or he probably has friends who are climate scientists and has these conversations over wine, because I think he likes wine. That's what I've seen him say in interviews. Yeah, that seems to be, to me, the position. But again, all you 1 and maybe 0.5 listeners out there, what you get here is the long form version of that. However good or bad it is. But anyway, we're happening upon that normal time when we say goodbye
and shed a tear for the world which is over the edge of parts per million, and we're fucked.